Astronomers use radio telescopes to study distant stars and galaxies. They use a band of microwave frequencies reserved for scientists studying the heavens and the Earth.
By international treaty, there's no intentional transmissions allowed in this band, so I can't set up a television transmitter, say, and operate here. It's dedicated, set aside for what we call passive use, or in this case, the microwave radiometer listening to the natural signals from the Earth.
NASA is using this band to study the water content of soil for its Earth-observing SMAP mission, which stands for Soil Moisture Active Passive.
The active-passive part really refers to the instrument. So the active portion is a microwave radar, and the passive portion is a microwave radiometer that we built here at Goddard Space Flight Center.
Every molecule naturally gives off or absorbs microwave energy to maintain a balance with its surroundings. The amount given off by the soil depends on its temperature and its water content.
The molecules in the soil with the water, they're bouncing around off of each other and emitting microwaves. And the dry soil lets out a lot of these microwaves, and the wetter soil lets out fewer of these microwaves. The challenge is that the neighboring bands have radars and communication systems, and some of those transmissions can unintentionally leak into our spectrum. So we had to develop dedicated technology for SMAP to try to separate out the natural signals from the Earth and the human-made signals that we don't want. The signals that we want the SMAP radiometer to listen to, they vary slowly in time. They're very broadband, and in fact, what they are is it sounds like if you were to hook up a radio receiver and listen to it yourself, it would sound like noise, just sound like static. So we look for signals that don't look like static, and that's what we want to throw away and then keep the static for ourselves. So the team here at Goddard developed specialized hardware and software. It separates out the signals that the radiometer receives in time and frequency, and for every spot on the ground, it looks for outliers, and if it sees those, it just removes them from the measurement and throws away the bad, keeps the good, and produces the data to give us good measurements of soil moisture here today to allow us to improve weather forecasting, drought and flood predictions, and forecast crop yields better.